Writing a suspicious activity report, or SAR, is a severe operational bottleneck in anti-money laundering compliance. Under traditional workflows, drafting a single SAR takes an investigator up to 315 minutes, while global transaction volumes are scaling exponentially. A common yet flawed industry assumption is that we can solve this simply by feeding raw case data into a monolithic large language model and prompting it to write the report. When deployed against the complexity of real-world AML case files, standard generative AI models exhibit hallucination rates between 20 and 30%. They fabricate transaction events and invent interactions that never happened. This failure occurs because standard LLMs lack alignment with specific financial crime typologies. Furthermore, when forced to process overlapping transactions, multiple subjects, and extensive historical data, their reasoning collapses under extreme context window limits. Financial regulators require strict 100% evidentiary traceability for every claim made in a SAR. The opaque, black box nature of a hallucinating monolithic LLM introduces an unacceptable legal risk for any reporting institution. To automate compliance reporting at scale, the architecture requires two structural shifts. First, identity resolution must move from probabilistic record screening to deterministic data clustering. Second, the AI reasoning layer itself must abandon single, monolithic prompts in favor of a multi-agent architecture. This diagram illustrates agentic AI, a distributed system where specialized autonomous agents execute specific deterministic tasks through a continuous perceive and act loop. Achieving regulatory-grade automation requires physically separating the underlying data environment from the AI reasoning layer. Accurate AI reasoning is impossible if the underlying data consists of fragmented, redundant customer records containing slight variations in spelling or formatting. Legacy compliance systems evaluate transaction risk at the individual record level. When simple typographical errors exist across different internal databases, these systems generate massive volumes of false positives, evaluating the same entity multiple times. We resolve this at the API ingestion level through Universal Customer Identity, or UCID, clustering. This begins with the FP2 matching algorithm. First, SimHash generates a 64-bit fingerprint for the strings, allowing for hyperfast initial comparison. Next, the strings are broken down into interlocking three-character sequences, known as trigrams. This mathematically detects misspellings by highlighting overlapping sequence matches. Finally, the Jaro-Winkler algorithm computes a definitive similarity score. It handles token reordering and confirms the match. Transaction monitoring scenarios, such as velocity thresholds and geographic anomalies, are now applied directly to this single, unified identity cluster. If a bad actor attempts to spread transactions across multiple fragmented accounts to evade reporting thresholds, the system detects the aggregate structuring behavior because the underlying identity is already resolved. This UCID clustering is entirely non-destructive. It preserves all original data payloads and maintains complete audit trails for future regulatory review. By engineering a deterministic data layer first, the system eliminates redundant false positives before the complex AI reasoning phase even begins. This schematic details the reasoning phase. Data first passes through the AI privacy guard, masking sensitive entities before touching external models. Anonymized data reaches central orchestration, where the planning agent dynamically spawns specialized typology detection agents based on extracted risk indicators. Distributing analytical logic across these specialized algorithmic agents prevents the context window collapse that causes monolithic LLMs to fail. Analyzing internal data is insufficient. Robust compliance requires correlating internal transactions with constantly shifting external watch lists and adverse media. During an investigation, the external intelligence agent is responsible for gathering this outside context. It achieves this using the Model Context Protocol, or MCP. MCP is an emerging open standard that allows secure, tool-agnostic AI integration, eliminating the engineering bottleneck of building and maintaining bespoke, hard-coded APIs for every new data source. External data pulled via these standardized servers, such as global adverse media events, is routed directly back to match the specific UCID cluster being investigated. By adopting MCP, static compliance tools are transformed into a dynamic intelligence network capable of real-time contextualization.
Once the specialized agents conclude their analysis, they pass their localized findings to the narrative generation agent to synthesize the final suspicious activity report. This transcript shows the agent's explicit chain of thought reasoning. To guarantee explainability, it outputs logical steps, identifying facts, patterns, and red flags before drafting. The agent maps these facts directly to FinCEN's structural requirements, clearly defining the who, what, when, and where. Before the report is finalized, it is evaluated by the compliance validation agent, utilizing an agent-as-a-judge automated methodology. This automated judge audits the narrative for semantic coherence and strict regulatory rule alignment. It ensures 100% traceability and compliance accuracy before a human investigator ever reads a single word. The front-end data flow takes raw, fragmented ingestion, organizes it through UCID clustering, and secures it behind the privacy guard in milliseconds. The data then moves rapidly through the specialized reasoning agents, gathers external intelligence, and passes through the final automated validation layer. This orchestrated architecture executes in a fraction of the time it takes an investigator to complete the standard 315-minute manual drafting process, while simultaneously enforcing higher accuracy. This architecture maximizes human-in-the-loop efficiency, ensuring the investigator's judgment remains central to the final disposition of every case. When a draft is ready for review, the feedback agent securely unmasks the privacy-guarded entities, allowing the investigator to read the narrative with full, accurate context. The compliance officer interacts with the system to verify the logic and refine the draft. These structured feedback loops finalize the report while simultaneously training the model for future cases. Investigators operate as strategic reviewers, focusing effort on high-level decision-making rather than the manual collection of data from siloed tools. Anchoring agentic AI in deterministic data allows institutions to safely scale operations against evolving financial crime. Compliance moves beyond reactive cost management, providing firms with proactive, data-driven insights into institutional risk.